Welcome. Thank you very much for coming here. I know it's pretty late and a lot of people are already heading home. Welcome to Jakarta EE Recipes. This is actually originally not a talk that I had accepted. This is a talk that was accepted by George Juno, a good friend of mine. The talk is his format. I am going to respect that recipes format the best I can, but I'll add a little bit of my own spin to this as well. So this is actually a talk that I intended to be open source in the sense that all of the material for this talk I'm intending such that anyone can take this talk and deliver it themselves. What I'm going to deliver in this talk today is talking to you a little bit about the context of what Jakarta EE8 in particular is and what it means to you. Then we'll talk about a little bit of a brief tour of the Jakarta EE8 features in the context of precisely what the use case for each of these features are. Lastly, I'll also talk a little bit about what the future looks like and what some of the current challenges and promises are. And one of the things implicitly that I think I'm trying to tell you is that you do need to get involved to make sure both the promises are realized and the risks are minimized. Okay, and maybe we can have a discussion a bit later about what that means and what you could help do to make those a reality. Okay, so first and foremost, we are now in the era of Jakarta EE. Hopefully, most of you are probably Java EE developers. So now you can rebrand yourselves as Jakarta EE developers. In a sense, what precisely does this mean? What this means is that Java EE, the technology that we used to know as Java EE, is now moving into a fully open source governance model. It is no longer, the IP is no longer controlled by a single entity. The process is no longer controlled by a single entity. And the TCK process, the certification process, is no longer controlled by a single entity, but rather under a nonprofit organization, the Eclipse Foundation, and controlled by all of us. Obviously, there are vendor stakeholders like IBM and Red Hat and Tommy Tribe and Payara. But at the end of the day, what I would hope that you will take away from my session today is it is not just those few vendors. It is all of us that need to be involved in defining what Jakarta EE is and what it means going forward for server-side Java. If this is done correct, it will extend the life of server-side Java and the life of Java, I believe, at least for the next few decades. If we mess this up, I have some real concerns whether what the future for server-side Java is going to be and whether it is going to be as healthy or as robust as it has been. So this is a very, very critical time. You are experiencing a very important part of your professional life cycle, and perhaps you will need to do a bit more than what you have been used to in the past. So there is something important that I want to talk to you about, and I will tell you this is a point of pride. The scope for Java EE8 was defined, and hence transitively, the scope for Jakarta EE8 was defined in a very unique way, and in a way that really has been not done for any major technology so far. Okay, and I hope that this will continue moving forward, and this is something we can talk about as well, continue moving forward for Jakarta EE. The scope for Java EE8 and Jakarta EE8 was defined not by a bunch of people behind closed doors, but out in the open, right? We actually put all of the ideas that the people that would have been worked behind the scenes out in front of the community, and we said, please, community, give us input, vote on what these features are, tell us what is important. And that is ultimately what determined what the roadmap for Java EE8 really looked like. So what is Java EE8 or Jakarta EE8? So one thing you need to know is that Java EE8 is basically equivalent to Jakarta EE8. Really what has changed is a governance model, right? So now if you want to be certified as a Jakarta EE8 implementation, you no longer need to go to the Oracle. You no longer need to go to the JCP. In fact, you can just contribute to the TCK and run the TCK completely in open source. That is hugely important and hugely significant in terms of where this can go and how this can revitalize what we know as server-side Java. There are some key themes for Jakarta EE8, and these are the key themes. One is web standards alignment, and this is a rather important one. Just like server-side Java has been reinvigorated, we hope, with Jakarta EE8, if you've been paying attention to the web standard space, that has also been reinvigorated. So all of these specs that used to be rather static and hadn't changed for almost decades or more than a decade, things like HTTP, those are finally moving forward, and they continue to move forward. So an important part of what we needed to do in server-side Java and Java EE is align with these trends, enable server-side Java developers to take advantage of these innovations that are happening in the web standards. So these we'll talk about in more detail, but some of the key examples are HTTP2, server-side events, JSON binding, JSON processing. These all have been absorbed from the web standard space into the server-side Java space through Jakarta EE8. CDI alignment, this is another important one. So if you've kept track of the history of Java EE8, largely right now we have several different component models in the platform. We have the CDI component model, we have the EJB component model, we have the JSF management component model, and there are other such implicit component models. Now, in order to have a cohesive platform, you can't have these sorts of duplications. It's a waste of effort, and also it's not as seamless of an experience for the developers. So what you need is cohesion around a single programming model, and the programming model that makes the most sense is CDI. So we've been doing this work for a little while, and we've done some more incremental work in Jakarta EE8 to make this alignment happen. So first and foremost, we have no longer a point release, but a major release of CDI2. So we haven't had one in Java EE7 or Java EE7. Now with Jakarta EE8, you actually have a fundamentally a significant release in terms of CDI2 that helps that alignment going forward. Okay, and we'll talk a little bit about why that is. We've pruned some EJB features. I think we need to continue to do that, and also we'll talk about this in a bit later, move some of the features that are currently sort of implicitly tied to the EJB model into the CDI model that hopefully we can fully deprecate EJB at some point in time in the future. I hope maybe as early as Jakarta EE9. Concretely, we've also now pruned with Jakarta EE8 one of these duplicative programming models, and that happens to be Jakarta Faces Manage Beans. Okay, so don't use that anymore. Use CDI with JSF or Jakarta Faces instead now, because the Jakarta Faces standard has allowed you to do that. Is recommending that you go do that. Is you use a cohesive programming model with CDI. We've had some long pending and interesting work in the security specification that is very relevant to enterprise development and microservices development as well, and that we can build upon going forward. This is a solid foundation that was necessary. We'll talk about what these changes are. As you know, one of the key value propositions for server-side Java is that it takes the innovations that happen in Java SE and democratize it and it tells you, okay, these are the ways you can use these innovations. So in the same way, you needed to absorb some of the features that happened in Java SE8 into Jakarta EE. So some of that work has happened in specifications like Jakarta Faces, Jakarta Persistence, Jakarta REST, and Bean validation. Some of the work is still pending, and I believe needs to happen in a subsequent release. We'll talk about what has happened and what has yet to happen towards the latter part of the presentation. So one of the biggest innovations, I think important innovations in the web standard space is HTTP 2.0. This is basically almost a fundamental rewrite in terms of the behavior of the HTTP2 specification. Remember, HTTP1 and HTTP 1.1, in fact, is about more than a decade old now. So it is designed with a very different model and different view of the web in mind. So this is the world where really you would access a largely textual page, and the textual page would maybe have a few graphics in it, and then you would click on that page and it would take you to a hyperlink to go to another page that looks very much textual and maybe has a bit more graphics in it, but that's about it. So in that world, the model that made sense is a stateless single request to single response mapping. Okay, but the problem now is that that's not the web today. If you look at the web today, you're talking about single page applications, you're talking about applications that are very rich, have a lot of content. And in fact, Google did a study on this several years ago, and what they found was for a given page, you have 40 different dependent resources that page loads before it can meaningfully render its functionality. So what this means is that that single request response model really does not work, right, in that world. What you need is a multiplexed connection, whereas you open up a single stateful connection as opposed to a stateless connection, and you reuse that connection to transfer all of the resources that you need for that single page unit. So that is really what HTTP 2 does. It almost uses HTTP 1 as infrastructure and builds upon that, and basically turns it into a stateful set of connections where you can multiplex requests and you can even multiplex streams. So in the single stream, you can exchange multiple resources. You can also more intelligently from the server side say, hey, you requested this resource, but these are these other 35 resources that you will also need. Well, you don't have to explicitly ask for those. I'm just going to give it to you right when you initiate the single connection. Binary also in HTTP 2, HTTP 1.1, as you know, was a textual protocol, right? So if you would open up a TCP view of the connection, you'd be able to see what data is being exchanged. The problem with that is it's relatively slow, right? You need ASCII or rather textual encoding and decoding on both sides to make that happen. HTTP 2, on the other hand, uses binary framing. So it's much more efficient in terms of its ability to transfer. And there's also other duplicative things that also happen, like headers. So the header exchanges, because it's stateless, each time you're exchanging the same set of headers over and over again over the same set of related resources. All of that has been compacted down, and all of that redundancy was reduced in HTTP 2 using a technique called header compression. So in the end, what does HTTP 2 give you over HTTP 1.1? It's almost 3 times perceived performance improvement, okay, for a single given application. This is a huge benefit that you absolutely should take advantage of. And this is basically what Servlet 4 largely brings you, okay? So Servlet 4 says that an engine that is certified against Servlet 4 underneath the hood is going to absorb all of these changes for you. And it guarantees that the runtime that is saying it supports Servlet 4 actually properly supports HTTP 2.0. Okay, so this is the only guaranteed mechanism that you have in server-side Java. So the real value proposition in Servlet 4 is the TCK to verify that a runtime actually implements HTTP 2.0. Luckily, these changes can be absorbed without large API changes in the Servlet API. The Servlet API is designed such that it doesn't actually need to change if fundamental protocol layer behaviors change. Okay, so there is a single API change that occurred with Servlet 4, and that's only for server push. But by and large, everything else is transitive to you. So the big use case here is honestly almost a no-brainer. You would absolutely want to upgrade to Servlet 4 and want to upgrade to HTTP 2.0 to take advantage of that performance benefit if you at all can. Okay. Jakarta JSON binding. So we had a JSON processing API as of Java EE 7. It's called Jakarta processing. Okay, JSON processing. What that is basically it is the JSON or XMLP equivalent for JSON, namely a low-level API that looks like DOM or SAX that allows you to parse and generate JSON content. But that was just the beginning. What we actually needed in Java EE is to make JSON a first-class citizen of the platform, just like Java serialization is, or just like XML binding is, in the sense that you should just be able to take a POJO and say, just serialize this to a JSON stream. And that is basically what the Jakarta JSON binding API does. And it is designed in a way that I'll show you in a second in terms of a code example, that you don't actually need to do anything to a POJO for the most part. You can just take the POJO as it is and just say, go and serialize this, just like you would by and large for Java serialization. Now, as you know in Java serialization, there are a small number of annotations like the transient keyword or the transient annotation that allows you to control that serialization process. Okay, so similarly in Jakarta JSON binding, you have similar sets of small set of annotations that will allow you to customize what the ultimate serialization and deserialization behavior really looks like. The biggest use case for this is really the end protocol APIs like REST. Okay, so when you have a REST API, let's say using the Jakarta REST API, because the JSON binding functionality is built into the platform, you can just say, hey, I want to produce JSON by specifying MIME type application JSON, or you want to consume JSON, and everything just transitively happens for you behind the scenes. That is what it means for JSON to become a first-class citizen of the platform. So here's an example of it. So I have a simple, as you can see, a get endpoint. It produces application JSON. It produces a POJO person. The person POJO does not need to have any annotations in it whatsoever. All you really need to do is construct the rather person object in the POJO world and simply return it from this REST API. Okay, because under the hood, everything is already pre-configured for you. This object is going to be automatically serialized for you in its output stream, and you'll get an output that looks like what is on the right-hand side of the screen. Yes, sir. Jaxorus already did that, but it did that in a proprietary way, right? So it did that using essentially a variant of JAX-B, whereas this is essentially a standard mechanism to do that. So it's portable across application servers, and the behavior looks exactly the same, as opposed to JBoss REST-easy uses JSON, and Glassfish uses JAX-B, and some other provider uses something else, and so on. So the behavior here is uniform, okay? So as opposed to being distinct. Yes, sir.
Just to add to that, the benefit from a developer's perspective is that the API for customizations on this serialization is going to be standard.
Exactly. So yeah, ultimately the customization behavior is the same. If you're not doing it in this way and you're manually parsing and processing JSON objects, that API looks exactly the same, as opposed to having divergent APIs like JSON or JAX-B or whatever else may be. Over here, you have a uniform API to do these things. Now, there were some small changes to the Jakarta processing API that was introduced in Java EE 7 as well. Namely, this is about absorbing, again, the changes that are happening in web standards. I'll talk about that in a second. So the two principal JSON standards that were absorbed are JSON pointer and JSON patch, and these happen to be reasonably well-used APIs in the web standards space. You'll see why in a second. And also, again, similarly, adapting to Java SE 8, innovations in Java SE 8. So here's JSON pointer. I think it's reasonably self-explanatory what this is. So the URL path that you see here is basically, by virtue of specifying that path, you are navigating to a specific element in your JSON document. So this makes it a lot easier to parse complex JSON objects, as opposed to manually using maybe a recursive algorithm to traverse the tree. The tree traversal is basically being done for you by implicitly specifying a URL-like path, and you can navigate to exactly the point in the JSON document that you would like. JSON patch is also very interesting. What this does is that, obviously, when you have a JSON object that you've parsed, you can manually make changes to it, right? So you can, there's CRUD operations that you can apply using the JSON processing API. However, what JSON patch does is that it standardizes even those changes, right? So this basically says these are the operations that you would likely want to perform on a JSON object. So things like add, replace, remove, copy, test, so on. And you can express those changes in terms of JSON as well. And you can, as you can see, in order to do that, you would implicitly make use of the JSON path APIs as well. So let's take a look at a quick example. So the two examples that I'm showing you. So in the first example, I'm replacing a value at an edge node. Okay, so I'm saying alter the value that is at this path. Okay. Similarly, in the second case, I'm saying take whatever element exists in this path, remove it. Okay, so it's a very compact way of expressing those sorts of operations, and moreover, it's also reusable. Okay, so if you want to make the same set of changes in multiple places, well, you don't need to rewrite that code over and over again, right? So you can simply reuse the same bit of XML patch and simply apply it to the document. I won't talk really much about the Java SE API changes, but what they basically allows you to do is be able to produce, transform JSON API collection objects into streams. Okay, so that's what the change there is. It's an API change that was absorbed. So let's talk about SSE. Server-side events is yet another innovation that was in the web standards space. What exactly is it? So hopefully most of you know a bit about WebSocket. Okay, so on one hand you have HTTP, and on another hand you have WebSocket. Okay, so in the HTTP case, what you're doing is you're doing single unit exchanges, request responses. You make one request and you get one response back. In WebSocket, it's a full duplex communication in the sense that you can make multiple requests, but the requests can originate either from either side of the connection. Okay, so it's either the client or the server can initiate the connection. HTTP is best for essentially websites or perhaps REST-based operations that would be atomic, right, and idempotent. Whereas WebSocket would be ideal for cases like, for example, a chat application or an online gaming application where the communication can initiate either from the server and or the client, and it needs to be a fully stateful stateful communication chain. So SSE is something in between that, and it's a surprisingly common use case. So in SSE, what happens is under the hood, SSE is really nothing much more than a long-lived HTTP connection. Okay, so you initiate a HTTP connection between the client and the server. Typically, the client will initiate the connection, and the server, and this connection will persist over a period of time. However, instead of just getting a unit response from the server, what you will get in this case is multiple responses, multiple unit responses over a period of time. So what is the use case for this? A good canonical use case is stock tickers. Okay, so you want to connect up to the stock engine and tell the stock engine, hey, I want to subscribe to this particular stock. And over a period of time, that server will tell you what the changes to that stock actually are. Similarly, monitoring applications, right? So if you're monitoring the state of whatever it is that you're monitoring, let's say a factory, right? So you can connect up to all of the nodes that would publish information about your factory and visualize that information that are coming from all of these different nodes onto your master monitoring screen. So that's what SSE is all about. At the end of the day, really what it is again, it's vanilla HTTP with a specific content type, okay, that indicates that this is not just a normal HTTP request, and that is text/event stream. Okay, and again, that's all built into the W3C standards. And again, the way this is delivered to you is largely via Jakarta REST 2.1. So this is how the API looks like, without going into great details of the API. So here's a normal, just a RESTful interface. And what you do here is that you connect up to this REST interface through the GET interface to say, hey, give me the quotes, and what happens here is you can start a thread in parallel using the executor service, and as new events come in, you can trigger a new event that ultimately is passed on to the client. So just like you have a server-side API, you also have a client-side API for this as well that I won't show you. Jakarta security is, as I said, security in Java EE has been funny for a little while. So you have all these fragmented bits and pieces, none of which are really cohesive. So you have JASPIC and Jazz and Java SE security and so on. So there really has never been a API-level cohesive answer to Java EE security. It's always, because of these bits and pieces, it's always been rather vendor-specific. Normally, the way you would Java EE, the way you would go about securing an application is rather vendor-specific, right? You would go into the App Server console and say, hey, I'm going to use LDAP to secure this application. And this is how my role to group mapping looks like, and it's all done either through a proprietary console or proprietary command line application or proprietary XML configuration. So the principal purpose of Jakarta security is to get away from that and give you a uniform API that is cross-platform and that you can build on going forward. I think once you look at the examples, it'll be a bit more clear what that means. Right out of the box, what you have is LDAP and security providers for database and LDAP. Okay, again, when you look at the examples, it'll be a little more clear what I mean by that. Yes, sir. Pardon? Not Kerberos yet, no. Yeah. Okay, so first of all, simple security providers. So let's say all you really want to do is you want to say this application is secured by a database, or this application is secured by LDAP. Well, guess what? Again, you can very easily do that now just by placing either of these annotations in your application somewhere. Okay, and that will implicitly create a security provider for you, and your application can then be secured against this identity data store. So it's as simple as that, as opposed to going through the proprietary ways of doing this in the past. Now let's say for a moment that your security needs are not met by either LDAP or database, and you want to do something else. Let's say you have a proprietary identity repository that you use that uses a specific protocol to do that. In order to do this in the past, you'd have to go through quite a few gyrations. You'd have to write your own Jazz module and configure it using JSPIC and so on and so forth. Well, now it's as simple as this. Okay, you can just create an application scope bean that extends the identity store interface, and the identity store interface has one single method called validate that takes the credentials. Usually the credentials are username and password, but it could also be a certificate. And then you do whatever you need to do, and then you provide the credentials validation results, namely whether the credentials was successful and what the approved roles are or the logged in roles are for this user. Okay, so very, very dead simple extensibility in terms of security providers. There's also a standardized security context. So this is another case where in Java EE things were very fragmented, right? So you'd have a user context in EJB, a user context in servlet, and the API looks slightly different. So in this case, it's a universal security context definition. The API is the same across servlet and EJB, and hopefully we can deprecate both of those APIs now, because now what you can do is you can simply inject the security context, just like over here, and get whatever you need to get in a standard fashion. This is especially powerful when you're writing interceptors. Okay, so for example, in this case, if you're writing a security interceptor for auditing, you can write the API this way, and this API will work the same way whether you're applying this interceptor at the web tier for servlet or at the business tier for EJB or for any other tier for that matter. Some changes in CDI too, namely Java SE Bootstrap. So now you can, CDI used to be a Java EE specific technology. You couldn't actually, there was no standard API for starting it outside of Java EE environments. Now there is, okay? This is an important thing when you're talking about making specs self-contained. Okay, so if you want a self-contained JAX-RS specification that doesn't depend on anything else, if you have a specific implementation of, let's say, JTA that you want to use outside the container, or if you just plain old have a Java SE application that you want to use CDI on, well, you can do all of those things now. In addition, yes, sir?
Isn't this important for CDI2 to be used for microprofile?
Precisely, yeah. So now you can.
Without that?
Yep, you cannot, yeah, in fact, you cannot. And in addition to that, there is also modularity. So now there is a core and then an SC and an EE profile for CDI. And this is useful for consuming CDI in various other specifications. So if you're writing a specification that doesn't need the EE features of CDI, that you can use that by simply using a specific sub-profile of CDI. Asynchronous events is something I'll show you in an example. The portable extensions API has also been improved through field experience to get, so basically getting other people's input on what needs to be changed in the CDI SPI, and that will allow you to use CDI for creating your own third-party integrations with Java EE. And there were also some Java SE8 alignment work done here as well. This is an example of asynchronous CDI events. Okay, so basically, as you know, CDI events prior to in Java E7 was basically synchronous. Okay, so you would fire, and then that event would be triggered at the observer level in the same thread. Okay, and in a blocking fashion. So now this is all non-blocking and also asynchronous, right? So you can fire the event asynchronously, and it will also be absorbed by the observers asynchronously as well. So this is better for in terms of its thread management semantics, right? So you're not sort of locked up doing the when you're firing the CDI event. You do the fire, and it just happens behind the scenes. This is very useful again if you're writing third-party integrations based on the CDI event bus. So Java SE8 was designed in a way that's relatively forward compatible, right? So what that means is a lot of the features in Java SE8, things like lambdas, for example, are mostly just usable as is, okay, in Java EE applications or Java E7 applications. However, there are definitely some cases where Java EE needed to adopt innovations from Java SE8. Some examples would be repeatable annotations, or the datetime API, or completable features. And I've listed out some use cases where this would be useful. I'll show you examples of what those are. So for example, if you wanted to specify multiple annotations in Java EE annotations in a single spot, in a single class definition, you couldn't do that before. Right now you can, because you have repeatable annotations, and these annotations have been adapted to make use of Java SE repeatable annotations. Well, now you can repeat those annotations and get rid of a bit of unnecessary boilerplate code. Jakarta Faces and JPA in particular now automatically support Java SE8 types. Okay, so before, if you needed to do this, you'd have to write custom converters because those runtimes would not implicitly support this. Now you don't need to do that. So for example, you could have a JPA entity that uses type instant, okay, and then you simply specify the add temporal annotation to say, hey, how do I translate this into the database, and that will just happen for you without needing to write a custom converter. Bean validation is another one of those APIs that were adapted to the datetime API. So the add past annotation will not only recognize the old Java util style date, it will also recognize all of the Java SE util, or rather the datetime API types as well, just like I have an example here. Completable features is another interesting portion, interesting Java SE8 innovation in the sense that it introduces the notion of promises, okay, in Java. So it is not callbacks, and it is also not the old style listeners either, right? So both of those have their own problems, and this is basically combining both of those things. So one of the use cases is RESTful services, right, where you want to make multiple asynchronous invocations and combine them a little bit later, compose them a little bit later, and you can use completable features for that now. So that this work has also been done. There are a set of other changes as well. I'm going to breeze them over because I'm a little bit short of time, and I do want to get to maybe the more forward-looking elements of my presentation as well. But here's some of the other changes that prominent changes that happened in Jakarta EE8. Okay, so Jakarta EE8 was released not too long ago, actually just a week ago, literally, and you already have implementations, 3 different implementations that are Jakarta EE8 certified, meaning certified against an open TCK and an open governance process. So those are Eclipse Glassfish, not Glassfish anymore, but Eclipse Glassfish, Open Liberty, and Wildfly. You can go to this URL. It will list out what are the compatible implementations. And also, I really like this. When you open up this page, there's a download link. Okay, this didn't used to be there before. You hit the download link, and you'll actually be able to download the implementation that is compatible with Jakarta EE8. So please give it a try, right? So if you have a Java EE8 application, try it out. See how this works out for you. If you haven't upgraded to Java EE8 or Jakarta EE8 yet, and you're sitting in Java EE7 and Java EE6, hopefully this presentation has convinced you that it is worth upgrading, okay? And definitely try try that out as well. Try the upgrade path. Upgrade your application. Try out some of the new features and see how it works out for you. So let's now talk about the future. So again, I will tell you that one of the things that has been, we all know what has happened with Java EE the past few years. It's not a pretty story, right? But here has been the saving grace. There's two different saving graces that really has stopped our entire ecosystem from collapsing. Number one is the fact that we went through this entire scope of Jakarta EE through that survey. Okay, what this means is that Jakarta EE 8 for normal monolithic applications is actually a pretty good feature complete platform. Okay, so that has meant that people aren't wanting, they aren't in crisis mode if they're just writing mostly monolithic or coarse-grained applications. Java EE 8 is mostly meeting their needs. The other saving grace has been this other project called Microprofile. Okay, and what this project has been doing for the past few years is because we needed to do this transfer process, because we needed to sort out what was going to happen in terms of the future of Java EE, this body of effort has stepped up to meet the needs of developers that are not necessarily writing monolithic applications. Okay, so the folks that are writing very, very small grain microservices applications, well, they can use these sets of APIs. Keep in mind, there's a few characteristics that you should know about Microprofile. It is not an open standard in the sense that Jakarta EE is and Java EE 8 is. It is actually more along the lines of an open source project that produces lightweight specifications. Okay, you'll see that. It'll be obvious when you look at the Microprofile standards that is what they are, right? They are not what you are used to in terms of a mature standard that Jakarta EE 8 hopefully will be and Java EE certainly has been, okay? But if you have these use cases, you can be an early adopter and make use of these APIs. I won't, hopefully you've seen a few Microprofile sessions, so I don't have to tell you what these features are all about. They are valuable features, especially if you're no longer really writing monolithic applications. Now, I told you about challenges and opportunities, okay? So I have to tell you, if you're paying any attention, you should be concerned, okay? While it is a very good thing that we have arrived at this point where we can say we have successfully completed this enormous transfer from the JCP to the Eclipse Foundation. And this is one of the largest technology transfers that have ever happened in our industry, okay, and that we've successfully finished this. That's no meager accomplishment. But there are other concerns. There are things that we need to sort out. So what we did was we actually had a Jakarta BOF for this conference. And Ivar Grimstad, who's now going to be soon to be the official evangelist for the Jakarta EE platform at the Eclipse Foundation, and myself, we said, okay, let's open up. Let's see what's on the mind of the community. So we created an open document, a Google document, and collected people's concerns, okay? And these are some of the concerns that people are concerned about, right? And these are legitimate concerns that we must answer properly. If this platform is to go anywhere and is to succeed, we need to have the right answers for these questions. And these are the questions I hope you are asking yourself, but don't stop at simply asking those questions. Okay, I'll tell you in a moment where you go from there and how you help make sure that this is a technology that succeeds in the next decade or more than one decade. We now have to, because of the branding concerns, we needed to rename from Java EE to Jakarta EE. We also need to shift the namespaces. We can no longer use the JavaX namespace. We need to move to the Jakarta namespace. It is still unclear what that strategy is, right? Yes, sir.
Please point out that the namespace change only applies to Java packages.
Correct. Okay. So as far as we know, the namespace change is only applicable to the top level packages. Okay, so top level packages need to change from JavaX to Jakarta. Okay. There's a lot of questions about how do you solve backward compatibility? Do you do this all in one go, or do you do it in an incremental fashion? What works the best for this industry and this consumer base? what will be the relationship between microprofile and Jakarta EE? Okay, it was not a very big concern. It was very clear what the relationship was when the transfer process was occurring, and we were moving from Java EE to Jakarta EE. Now that that process is done, do you need microprofile to be a separate thing anymore? Or does it make sense for these things to be aligned or merged in some way? Okay, this is a legitimate answer you should ask yourself. And if it doesn't merge, then what are the implications? What are the kind of problems that we need to deal with in the next few years, and what does that ultimately mean to the success of either or both? What is the future? What are some of the specifications that should change, and what are the enterprise needs now, right? Is it just microprofile, or are there things that we didn't really solve, and Java E8 is not as feature complete as we think it is? How do we now re-engage the Java community, right? So, and make this more of a platform for just vendors to be working at, right? So, a few of us have been working in the JCP as really community members for a long time. We need to now expand our population, right? We need more people to be more like these a small handful of dozen people that have been doing this, and you have the opportunity to do so. So how do we convince you that you need to be doing this? There's a lot of fear and uncertainty and fear-driven decisions and fear-driven thinking in the stakeholders, okay? And that is, I know who that comment comes from, right? I know what is the ethos of that comment. Ultimately, you need to determine whether these fears and concerns are real or are they simply conceived, okay? What are you thinking? What is your outlook on Jakarta EE and microprofile on Java EE? And how big of a deal is it? How afraid are you of this package renaming? So I have tried my best to try to understand what you all are thinking, okay? So obviously, I've talked to the people that I know of and that for years have been used this platform, and try to understand where is their head. In addition to that, one thing I have is my Twitter followers, okay? So I can use these folks. I can ask these folks, please tell me, what are you thinking, okay? So I did a series of polls on my Twitter account to understand what are people thinking, and this is what they're telling me. And you should ask yourself how this jives with you. It jives with me, right? So all of what my Twitter following is telling me, all of the people that I directly work with for years are telling me this all makes sense, okay? But I will tell you, this is not necessarily what certain vendors are thinking, right? So we need to give them input. We need to tell them what we actually think, all right? What do we do with JavaX? People are okay ditching it. How do we do a move? Once and for all, or incrementally over many years? Most people want it to be done once and over with and move on. What do you want to do with microprofile? Merge it. Merge it with Jakarta. You want to have one thing, not two different things. Do we keep the Jakarta microprofile branding and microprofile packaging? No. We want one packaging that is easy to understand and cohesive and consistent. These are the answers that I'm hearing, but these are not the answers I'm necessarily hearing from all vendors. Some vendors, yes. Some vendors, no. What do I think is next for the Jakarta EE platform? These are just some ideas. Okay, so one of the ones that is already happening, Jakarta NoSQL. There's a guy from Brazil, his name is Otávio Santana. He's actually leading one of these specifications to introduce NoSQL into Jakarta EE. One of the things that we've been wanting to do, and we've made incremental progress towards, is deprecating EJB in favor of CDI. One of the things that isn't standardized in Java EE security yet is the kind of authentication mechanisms that are common in microservices. So these are things like OAuth2 and OpenID Connect and JWT. This exists in microprofile. It probably belongs in Jakarta EE because this is a very common use case. Just like you defined data sources and JMS providers and JMS sessions, and now with Jakarta E8 security providers, you can do the same thing for managed executors. Okay, so that doesn't exist today. That is still done in an application vendor specific way. There's still more work to be done in terms of aligning Java SE. So one of the key APIs that didn't do this work, and it's an important one, is Jakarta concurrency. So for example, Jakarta concurrency could be taking advantage of promises. It only makes sense, right? That is what the future of concurrency looks like in Java. It's promises. It's no longer features and no longer callbacks. So this important API needs to be refactored to make that happen. One of the survey results that we had was that Java developers want an MVC framework in addition to JSF. That work has started. It didn't finish yet. Maybe that is something we do for Jakarta EE going forward. So what do you do? Okay, this is where your part comes in. You need to be involved. I'll tell you the many different ways of getting involved, but one way you can get involved is stay tuned to the Java EE Guardians, okay? We're that small set of people that are trying to keep an eye on things and trying to bring a user perspective in all of this stuff, okay? So stay tuned with us. And if you don't want to do that, these are some of the other resources we can do, okay? So if you haven't heard it before, please check out Jakarta 1, okay? So everything that I told you today has actually been talked about in Jakarta 1 conferences, specifically forward-looking things, okay? So there has been each sessions for each forward-looking thing, and you can go check that out. You can chime in onto the Jakarta EE community alias if you have an opinion. You can chime in onto the Jakarta EE Twitter handle. But please do something, right? You can't do what you've been doing for the previous few years. It can't be just 5 of us or a dozen of us that are trying to represent the community. You all need to think about these issues and you need to show up, right? At least show up in the Jakarta EE community alias and chime in there and express your views of what you see for the future. Thank you very much. I very much appreciate it. My time is up. I will try to stay up here and do Q&A. Sure. Okay. I very much appreciate your time, especially at the end of the conference. Let's stay in touch. I definitely would like to connect with as many of you as you can on a one-on-one basis. Thank you.